Maurice de Kleijn studied Mediterranean archaeology and is a researcher in the Spatial Information Laboratory of the Free University Amsterdam, so the SPIN Lab. He is specialized in applying geographic information science methods and techniques in the domain of historical archaeology and heritage landscape research. And we've been working together with him for a number of years already. He will defend his PhD thesis soon. It's been submitted, so fingers crossed, everybody. Titled Innovating Landscape Research Through Geographic Information Science. At the end of 2017. You already have a date?
No, not yet.
No date yet.
No.
So the floor is yours.
Thank you. No, the reason why there's no date yet is because at the VU you first have to they first have to approve it, and then you can go to the Beadle to get a date. I'm presenting here the presentation titled Virtual 3D Archaeology in Rome, and the reason why I put Rens de Hond on it as well, because we basically did most of the work together. And that's also the reason why we always put both of our names on it. But Rens de Hond is over there. You can ask him questions afterwards if you want. Okay, I will be telling something about this unique collaboration between information scientists and archaeologists, for which we developed a 3D information system which allows us, archaeologists, to analyze our study area in such a way that we have never been able to do before. And it was a collaboration with a lot of eScience engineers, and I see a lot of them here. It won't be the same story as I've been telling the last couple of years. Half of it will, but then afterwards there will be a vision to the future. So let us first bring us to our beautiful landscape and our beautiful study area, because we are studying the Via Appia, and the Via Appia is known as the first paved road of Europe. And the Via Appia was a road that went from Rome all the way south to Brindisi, and it had a really important commercial purposes, but also religious purposes, military purposes. The soldiers from Rome went all the way south to Brindisi to march and to go conquer the east. It had a really important funerary function, because what did the Romans do? They did not bury their dead inside of the city walls, but they buried their dead outside of the city wall. And the more important you were, the bigger your grave monument was. And we had the luck that we can study, that we have the area between the 5th and the 6th mile near to Rome, so the center of the world in antiquity. And you will find there the most prestigious and the most beautiful grave monuments alongside it. And our aim as archaeologists is to reconstruct how these monuments look like, what they, who was buried over there, what the social context was of that particular person, but also what changed afterwards, what changed from antiquity until now to the beautiful landscape that we are walking, that we can walk on. So just to show you this picture, what are we looking at? What are we confronted with? So this is our study area. What do we see? We see this ruins over there. We see the beautiful road in the middle. We see some trees. But actually what we are looking at is a really complexly layered landscapes, because here are some ruins, some antiquities. These cobblestones over here, they are put there, I think, 30 years ago. I'm looking at Rens, 30 years ago, something like that, yeah. There's some trees over here, and there's a wall over there. You can see it here. And these trees have been put there in the 18th, 19th century to create this romantic landscape for philosophers to walk on the Via Appia, to have a direct connection with antiquity. So we are confronted with a really complexly layered landscape. One thing that I want to point out, you see here this tufa slabs that you see over here. They look really authentic, really old, authentic tufa slabs. The whole road was created like that. But I can tell you they were put there in the 1960s, because in 1960 there were the Olympic Games in Rome, and the photographers had to stand over there while the marathon was going on the road to create this image of that they were doing the sports in antiquity. So, as I told you, we as archaeologists, we want to reconstruct the road. We want to reconstruct antiquity, how it looked like. And we are not the first one who did this, because this is a 19th century painting of Canina, and he thought that it might have looked like this. and he compared it with a lot of historical sources. He compared it with still existing monuments. And what we want to do within this project is basically a similar thing, but then in a more academic, transparent, and founded way. And we are using technologies for that. So just to get an idea, we have this 1.5 kilometer of road, which is our study area, and we have more than 2,500 objects scattered around. And we just have to, well, reconstruct which parts belongs to where. As you can see over here, this one is put there as a kind of museum piece, as a kind of open air museum, was also done in the 19th century. So we are confronted with the complex layers, also some renovating activities over there. And what we are doing, we are collecting, obviously with a tablet nowadays, but you could easily have done that in paper. We are collecting all kind of attributive information of every block of every archaeological site that we encounter. And we decided to measure everything in 3D because we wanted to have an information system which allows us to click on stuff and to get some attributive information on. This was already in 2011. We went there with a LiDAR, terrestrial LiDAR scanner, a car, with a laser scanner on top of it, and that car collected, within 20 minutes, it collected a big data set of, a point cloud data set for us. However, this method had some disadvantages because the car could obviously not go behind all the objects. So we combined this acquisition method with another method. We call it structure for motion, but it can also be called photogrammetry. Basically, the idea is that you take a lot of pictures of one object, you have an algorithm, and at the time that we started with it, it was really difficult to use these technologies, but nowadays it goes pretty easy because there's a lot of nice software being developed around it. So basically, you take a lot of pictures, and this algorithm creates a point cloud and creates a mesh around it of the object. So we have also the backs of these objects. The disadvantage of this method is that you don't have a scale and that you don't have the geographic position. However, if you combine the two, the terrestrial LiDAR and this photogrammetry, then you can combine these two and include in the and then you can include that in the tool that you have been developing. So I just grabbed this slide from the previous speaker. Never do a live demo by many people. So I'm not going to do a live demo. I will just show a video because otherwise I'm not a technology expert yet. So we have developed a desktop application. So here we are walking. We have developed this together with Groningen University. And here you can see these meshes being georeferenced inside this point cloud that was generated by the car. Here you see an object. There's this particular pyramid-shaped thing. And another tool that we've been developing together with the eScience Center is a web viewer. And this is quite nice because now we can, as archaeologists, now we can drive through our study landscape in a virtual 3D environment. And we have footprints for every brick. So, and to all the footprints, there's an attribute of information which allows us to query it, which allows us to ask questions like how many marble stones, or give me everything from the 4th century or whatsoever. What's happening right now is really spectacular because what we are seeing for us archaeologists is really spectacular because this is, I would say, big data. It's a couple of gigabytes of data, so it's not the volume, but it's all. Big data is also considered velocity and variety as well. And what we are seeing here is data being projected in a web viewer, which would normally not be, which at that time was not possible to project at once. And what we are seeing our study landscape with all the archaeological funerary monuments in it. We created a mini-map. We can ask a question, marble, and we get here all the objects that have marble in it. So this really allows us, as archaeologists, to ask things to our data sets which we have never been able to do before in such an interactive way. Here we can zoom into one of these monuments, There's a whole kind of attribute information behind it. We zoom into the monument. Here we see the drive map output, the terrestrial LiDAR part. Now we are projecting the structure for motion output on it. And just have a look at this beautiful funerary monument. We can do some measurements in this, which is really nice because some of these measurements, and this is actually 18 meter high. So for us, it's really difficult to measure, for instance, from here to there. Oh, I first have to go to the measuring tool. So that's 10 meters. It's really difficult to take measurements like this. So this really provides us with an analytical tool to conduct our research. And what we are doing as archaeologists, we are then using this instrument to develop 3D reconstructions, to develop 3D simulations, let's say, because there's no one truth of how one monument looked like. We are looking at scars like this, because over here we saw this scar of an anchor, and then we reconstructed it as an anchor. And you must imagine that in antiquity, all these funerary monuments were completely built with marble and with travertine stone. However, in the medieval period, Rome went from a city of more than 1 million inhabitants to this small town of 50,000 inhabitants. And one of their export products was the marble. And so a lot of churches in the south of Germany and in the south of France have marble stones from the Roman Empire, let's say, and from the Roman period. And also in churches, medieval churches, you still see a lot of these blocks being reused as well. So this is our interpretation, our reconstruction. Actually, it was the Master of Arts thesis of Rens. And here we can project it back again in our 3D tool. So until here, a lot of the eScience researchers have already seen this. So we have a cloud-based infrastructure where all our data is in. This point cloud data, this attributive information, the structure for motion, photogrammetry information. It's all in this. It's all somewhere in the cloud. And on top of that, we call it big data. On top of that, we have developed a desktop application. And within the desktop application, we can move stuff and we can georeference stuff. And we can also analyze stuff. But most of the users are using nowadays the web application where they query our data set and where they can access our information. The cloud infrastructure is organized as such that we can easily export the data to known 3D software, to known 3D modeling software. We can easily print it. You had a print with you, but I will show it in the end. And we also have a viewer integrated. It was an open source tool, 3D Hop it's called, and there you can see meshes instead of point clouds. So basically, you will be developing, based on a point cloud, a solid on top of that. And this is a picture of my French colleague who's sitting over there. We can eventually include this stuff in a virtual reality environment because it's structured in such a way that it can be put in. I think it was the Vive that we are using over there. And the good news is that almost everything that we have been using open source software. And most of the stuff that we have been doing is also available on GitHub, so easily being reused by others. So one of the things that these 3D Hub people made, that was from a European project, they did it in open source as well, so we could easily reuse their stuff as well. So I really believe this is the right philosophy, because we could have never been gotten this far without having the source code available as such. So now is the interesting part for those that have seen my previous presentations, because what's the next step? So the nice thing is that Rens has a PhD position gained based on this project. So that's already one thing. But from an academic perspective, what are the next steps? What are the things that we are looking at the moment? One of the things is virtual anastylosis, and it is basically the principle is quite straightforward. You have some bricks, and you let the computer calculate which would fit where. So the computer will help basically. The computer will help you in playing with the Lego, let's say. And the good news is that they released everything as open source as well. You can have a look at it. So that's also really nice. So we already have this infrastructure, and we already have these visualization tools that we have been reusing. And now we can have a look at what they did. And we did. We actually tried to look and to use their software, because this is a trench alongside one of our funerary monuments, and we found a lot of these stones, but not 5. We found like 100, and we had one of our students was really convinced and was really we had the idea of, well, let's try and do that, and he basically made 3D scans of all these blocks, and we have tried the software tools that are available, and we actually he basically, based on photogrammetry method, he created this 3D, and he was able to fit these to each other. And actually, we had a fit. We had 2 pieces that the computer was capable of matching to each other, and we were really happy with that. Of course, this is really trivial, and of course, we could have found it ourselves, but we were really happy that we succeeded in this. And one of the things, I mean, wouldn't it be nice if we can start up a continuation, a next project, where we just put in the 2,500 objects that we have alongside this via Appia? Why not? Why not see what comes out? And that might help us in years of research, of analyzing every brick. Let the computer help us in maybe reconstruct it and give a kind of certainty in it as well. So this is one of the ideas that we want to proceed, and hopefully maybe together with the eScience Center as well. Another thing that we are thinking of, and I was really interested also in this Jupyter Notebook stuff, because that might be something that we might be able to apply here. Because what we are doing, we are making these 3D reconstructions on how we believe that it looked like. And there's a whole discussion within the field of archaeology as well, whether or not we should call them reconstructions, because it's actually a simulation. We're not really sure how this object looked like. So what we basically want to do is, and we are already doing that, for every step that we took, we filled in a row in a database. So we know why we took that step, and we can include also alternatives on the various steps that we took in developing this 3D model. And wouldn't it be nice if we, because for instance, this funerary monument could have looked like this, but why not like this? We are comparing it with other sources, we are comparing it with other styles, but wouldn't it be nice if we can annotate every step? And we are doing that at the moment we are gathering this information, but wouldn't it be nice if we can do that in a structured, standardized way, so we can exchange this with other researchers as well that are doing similar things? Well, the good news is, at the moment, a lot of European projects have already got funded and released some interesting visualization tools online, but also standards. That's really crucial if you have standards for developing a 3D reconstruction or simulation, let's say. So I think it's really interesting if we can, and this is one thing I learned this morning, if we can include the steps that we are taking here with this hairball of information as linked open data, that we can relate every step also to pictures that we found in a museum or to other reconstructions of other scholars maybe. And I think it's really interesting if we are capable of doing that. And if we are capable of doing that, then the computer might help us by proposing certain objects in relation to each other, which helps us to interpret it, and which helps us to produce it in a transparent academic way. And one of the things that we want specifically to contribute is that when we have all this information in such a way, you can annotate it. There can be relational information behind it. It can be published as linked open data or whatsoever. But wouldn't it be nice if we can also include the spatial relationship between these different objects? So if you have, for instance, and I mean, the Romans were really like their funerary monuments, and their architecture was really like IKEA style. They really had these standards in it. So if you have a certain type of decoration here, you will always have certain blocks underneath here, and you will always have this kind of column type over here, and this base like that. Wouldn't it be nice if we can extract information based on these 3D reconstructions that are developed by simulations developed by other archaeologists? Wouldn't it be nice if we can extract a graph on it and not only see the spatial relationship between two objects, but also the linkage between three objects via other objects as well? Because it's the spatial context of different objects around it. And that's one of the things that we are currently working on, not for an archaeological project, but for bridges of Rijkswaterstaat. So the governmental institute that's responsible for our Dutch roads. We are currently working on an experiment with this, and I would like to apply this in the field of archaeology as well. And maybe this is also something where the eScience Center might help us in the future. And the last thing that we are working on, and we recently submitted a nice proposal for this, is that we want to create this museum exhibition for the Pierson Museum, where we are working together with an artist, Kleijn, and she took basically pictures of painters from the past, drawers from the past that created pictures of the Via Appia. She went to the exact location and went to take pictures on what we are seeing nowadays. And we basically want to include this in the hallway in the in the Pierson Museum, where you would see this kind of projections, and you can see this two layers being confronted with each other. What we want to add is kind of hologram, where you can see the object in 3D being printed, and then projected on top of that the interpretation of the archaeologist on how we believe that it looks like. And then at the end of the hallway, we want the people that visit the museum to be able to create their own 3D reconstruction. Because what they are seeing, and give them different scenarios on showing it like this or like that, and we will pre-process some things about them, because in that way we will teach them, we will have an interaction with them on the difficulties that we archaeologists have in projecting and presenting the past to the public. So back again to this slide, to conclude, all the stuff that we have been doing in this project is reusable. Most of the stuff is reusable, and you can all find it on our GitHub on our website, which is on the last slide. Because I definitely have to show you this slide, because I'm from the VU University, from the Spatial Laboratory. There's a lot of archaeological students from the Radboud University, and we could have never been doing this without the eScientist, without the eScience Center, University of Groningen, obviously, and the gas suppliers, NWO. I saw that from the other presentation. So we are really happy that we could achieve this, and we really want to continue this. So thank you. Any questions?
Thank you, Maurice. It was very interesting. I was wondering when you were talking about your idea for mapping, especially the spatial relationships, your research challenge as a kind of future research, to which extent we are here already dealing with standardized formats in architecture, because those funerary monuments seem quite different from temples and all other, and also having different sort of proportions. So are there in those funerary monuments, as you have seen so far, of course they are from different ages, but there will be also monuments of the same age, which more or less have a returning proportions or measurements, which makes it really useful to have this model of those spatial relationships, also to identifying specific styles and periods within well, the past of the Via Appia.
Yeah, so that's really interesting questions. I don't know the answer to that because I haven't been looking into the standards for that. I've been foremost looking into this London Charter, where there are standards in how you would publish your 3D reconstruction or simulation. This will be an ontology for architectural history. I have a look at Lorenz because you have been more into. I've been more focused on the application of geospatial information site methods and tools, and Rens is more the archaeologist, the architectural historian. So let's see what he has to say about this.
Hi. I think I can tell that at least we see a very strong typological classification in the remains alongside the road. So at least for now we can classify types of monuments and formulate rules or certain dependencies of components of the architecture within those types of funerary monuments. So that's the starting point, I think. And from that we will try to go into as much detail as possible.
And from that extent, it might be interesting to see what this Jupiter stuff is doing, because that will be a kind of procedural modeling, and where you can put in rules on it. It has 2 stories, it has 2 stores, it has a flat roof or whatsoever. So that might be an application of tools like that within this field. But I haven't seen examples of that yet. But that might be a pilot, something that we might come up with.
Let's thank the speaker.